Okay, hi there. I'm going to do a review session with you guys for getting ready for your next test on Chapter 4. And I'm going to just run through some review problems. So you should copy these down so I can give you a good grade on your notes. The first one is if I was just going to do a couple graphing problems, and I gave you the first equation here of y equals negative 2x plus 1. And, I asked you to do it with a table. You can make a table over on the side. I don't have a ton of space here, but let me do what I can. If I take an x and a y, and sometimes they'll give you numbers in the x column, and sometimes they don't. So if they don't, then you can make your own. Pick, negative 2, 0, negative 2, negative 1, 0, 1, 2. I'll do these 3 points with to start. If I plug in negative 2 in here for x, I get negative 2 times 2, negative 2 times negative 2, plus 1. So negative 2 times negative 2 is 4, 4 plus 1 is 5. If I plug in 0, anything times 0 is 0, 0 plus 1 is 1. If I plug in 2, I get 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. And there's 3 points. You could have used more points if you wanted. Don't use less. And now I can go and plot the points. All right, so I got negative 2, 5 is up here. 0, 1 is here. And 2, negative 3 is here. So that's how you'd make your graph if they asked you to do it with a table. We spent a bunch of time on that. Put some arrowheads on there, and there's the first one. Okay, questions? No? No questions. Great, moving on. Number 2, if I had y equals negative x. With this one, I'd like to do this one with rise over run, which is another way we did it. If you identify the slope and which is rise over run, and the y-intercept, you can graph it. Okay, now this one doesn't have a y-intercept listed. The y-intercept comes at the end over here, so if there's nothing there, you can always put plus 0, which means your y-intercept is 0, and my slope in this case is what's in front of the x, and once again, there's nothing written there, there's just that negative sign, which means you can always pop a 1 in there. Okay, so this would be a slope of negative 1. And if I make that into a fraction, that would be negative 1 over 1, because you can always take a whole number and put it over 1. I should scroll a little bit so you can see that. Overlapping my picture. Okay, so that is where we're at with that. If that gets in the way. You can see the graph on my head or if it overlaps it in the video. Anyway, I guess we'll find out. Work in progress. Thank you for everybody for your feedback on the last videos. All right, so if I'm going to graph this now, I can go back over here and I can start at the y-intercept, which is 0. That's where the line crosses the y-axis. Put a dot there. And then my slope is negative 1 over 1. Now, negative slope goes this direction, which means, that I should really go up and to the left. Okay, I'm going to switch back to red so you can see a little better on this. If I go up 1, left 1, up 1, left 1, because the slope is 1 over 1, negative 1 over 1, up 1 over 1, up 1 over 1, so on and so forth until eventually you get up here, and then you can make your line, and boom, there it is. Okay, so that's that graph. Now you could look at it and be like, does it make sense? Does it have negative slope? Yeah, it does. Does it have a y-intercept of 0? Yes, it does. Okay, all right. So that was that one. Now I was going to do one more that's a little more challenging with a fraction in it. So I'm going to make this one pink, and this equation will be y equals 1/5 x minus 2. All right, so this one, I'm going to do it with rise over run and the y-intercept again. Once again, this is the y-intercept, the number that comes, the regular number, not the one in front of the variable, and this is the slope. So if I start at the y-intercept, which is negative 2, because there's just a subtraction sign in front of it, put my dot on negative 2, And then I can do my rise over run, which is 1 over 5. Positive slope goes that way. You should have the 4 slopes memorized for your test. Positive goes this way, negative goes this way. Undefined is straight up and down, and 0 is straight across. So you should have those 4 memorized for your test. Okay, so rise is 1, run is 5. Up 1, left 5. 1, 2, 3, 4, 5. And there's my point. I ran out of space going to the right. And you can also go down and to the left. So if I go down 1 and then left 5, I go 1, 2, 3, 4, 5 over there. There's my other point. And then you can connect your dots and make your line. Okay. So those were the first few problems I wanted to go through with you. Next, I am going to do one of the table problems. Now, these are ones where if I gave you the table, I asked you to come up with the equation. What is the, I'm going to call this question number 4. What is the equation that goes with this table? Okay, so I got a table here, that, x, y, and we're going to start at 1, 3, 2, 7, 3, 11, and 4, 15. So that's my table. Now, I need 2 things for this equation. Once again, back to the linear equation, y equals something times x plus something. I need the slope and I need the y-intercept. The slope you can find by, taking the numbers and subtracting them. If I'm going, I usually go from the bottom towards the top, 15 minus 11, that way I get the sign right. It's 4. 11 minus 7 is 4. 7 minus 3 is 4. That's the rate of change, which you call slope. And that goes here in front of the x, okay? And the other thing I need is I need the y-intercept. Now, if they gave me a table where they told me what the y value was when x is 0, I would be all good at just plug that in after the x. However, in this case, it's not there, so I need to extend the pattern. Like how do you get from 15 to 11? How do you get from 11 to 7 and 7 to 3, which is subtracting 4 every time, which means if I take this and subtract 4 from 3, I get negative 1, and that is my negative 1 is my y-intercept. So that's the equation, and that's what I would be looking for. Questions? No questions? Great, moving on. Next one is number 6. What is the explicit formula that goes with this pattern? Oh, I skipped one. I'll go out of order. Here we'll go with number 5. Okay, and this is what is the explicit formula that goes with this sequence 8, 15, 22, 29. Okay, so with this, there's a formula that you have written on your formula sheets, hopefully. You should have it in your notes. It's a of n equals a of 1 plus n minus 1 times d. Okay, a of 1 is the first number in the sequence, d is the common difference, and n will be whichever number in the sequence it is. So when you're done, you should still have an n, but I should fill in the values for a of 1 and d. So a of 1 and d are the 2 values, make it a lowercase d, that I'm looking for. A of 1 is easy. It's the first number in the sequence. In this case, it's 8. D is pretty easy too. You can find D by taking the first 2 numbers and subtracting them. 15, second number minus the first number. 15 minus 8 is 7. This is an arithmetic sequence because you're adding over and over again or subtracting over and over again. And if you're multiplying or dividing over and over again, that's called geometric, which is something we'll get to later on in this course, but not now. So anyway, D is 7, which means I can now write my equation, and this would be the explicit formula. A of 1 is 8 plus n minus 1 is n minus 1 times D is 7. And that is the answer that we'd be looking for. And once you got the equation, the explicit formula, you can find out anything. If I ask you for, what's the 200th number in the sequence, instead of adding 7 over and over and over again 200 times, I could take 200 and plug it in for n and solve it and figure out what the 200th number is. In this case, 200 minus 1 is 199, and 199. I need a calculator quick here. 199 times 7 is 1393 plus 8 is 1401. So 1401 would be the 200th number in the sequence if they were to ask for that. Okay? All right. My next and last problem for you is this. Create a mapping diagram and determine if it's a function. So this is number 6. Create a mapping diagram and determine if it's a function. And my points are 2, 4, 3, 5, 4, 6, and 3, 7. Okay, so mapping diagram has inputs and outputs. Which we also call domain, and range, which we also call x's and y's. So I'm going to stick with those two, and the domain would be your x values, 2, 3, 4, and 3. Now, there's more than one 3 there. You don't repeat the 3 in the domain. You only show it once. So I go 2, 3, and then 4. Okay, and in the range, which is the outputs, that would be the y values, which in this case would be my 4, my 5, my 6, and my 7. 4, 5, 6, and 7. Okay, so now I've got, that's most of the mapping diagram. Now I need to go from one point to the other, which means, 2 goes to 4, which means I'm going to put an arrow that way. 3 goes to 5, 4 goes to 6, and 3 goes to 7. So that's my mapping diagram. Okay, so that would be half of the question. The other half is asking whether it's actually a function or not. Now, I told you earlier that, in the previous video that if it's a function, every input must go to exactly one output. If it's a function, every input must go to exactly one output. And therefore, since 3 goes to 2 different outputs, it's not a function, okay? And that would be the other part. And if they asked you why, you'd say, because 3 goes to 2 outputs. And a function, each input goes to only one output. Okay, and that was the last question I was going to show you guys today. And start studying for your test. And I will see you guys tomorrow. Bring any questions that you got into class. Thank you. Bye.